Hi everyone, this is the continuation of the last video regarding the basic limit laws. Here are the four remaining limit laws that we will discuss in this video for us to compute for the given limit problem that you can see in the introduction part of the first video about limit laws. Alright? So let's move on to the limit of the sum and difference of two functions. We all know that it's defined in the last video that if you're going to get the limit of the sum of these two functions, basically you can add their limits. But if you're going to get the difference of these two functions, then you subtract their limits, all right? So let's have the first example. Let's say if you're going to get the limit of x cubed minus 3x, all right? As our x approaches the value 3. All right. So in here, we can basically use this limit law. So this will become the limit of our x cubed as your x approaches 3 minus the limit of the next function, which is 3x, as your x approaches 3. All right. So by using the limit of the power of a function here. So this will become get first the limit of your function x as your x approaches 3 before you raise it to its exponent. Minus, so this will become the limit of the constant multiple. You just get the constant. So this the constant here will be equal to 3 times the limit of your function x as your x approaches 3. All right. So we're getting their individual limits. So you can get the limit of this function easily. All right. So in here, by the definition of the limit of the power of a function and the limit of the identity function, this will become 3. And you're going to raise it by your exponent 3 minus, you have 3 here times the limit of the identity function here will be equal to also 3. All right. So basically, by applying this exponent here, we have here 3 raised to 3, which is equal to 27, minus the 3 times 3, which is equal to 9. And by getting the difference of these two, you have here answer of 18. All right. So let's move on in getting the limit of the product of two functions. We all know that it is defined in the last video that if you're going to get the product of the function f and g as your x approaches the value k, so this will become the limit of your f times the limit of your m. All right. Let's start with the example number one. We have here getting the limit of the function f, which is x times the function g, which is, let's say, 4x squared minus 1. All right. As your x approaches, let's say, let's use negative 1. All right. So in here, we're going to get the limit of these two functions. You have first to determine the function f and the function g, which is a binomial function. All right. So by applying the law of the product of these two functions, this will become the product of the limit of your x as your x approaches negative 1 times, let's say, the limit of 4x squared minus 1 x approaches negative 1. All right. So in your function f, we can basically simplify this one as the by using the identity function, this will become negative 1 times. All right. So here we can still expand this by applying the sum and difference of two functions and for us to get their individual limits. All right. So this will become the product of negative 1 times the limit of your 4x squared as your x approaches negative 1 minus the limit of your 1 as your x approaches negative 1. All right. So I just simplify this negative 1 for us to lessen the writings on this whiteboard. All right. So this will be negative 1 times. You can still use here the constant multiple. So this will become 4 times the limit of your x. And by also applying the power of a function as your x approaches negative 1 and raise it to your exponent. All right. Minus the limit of 1 as your x approaches negative 1. Right? So in here, let's start simplifying this function g. So you have here 4 times the limit of your x by using the identity function here. This will become negative 1 and use your exponent. minus, by using the constant function here, the limit of a constant, this will become equal to 1. All right. So let's start simplifying this. 1. Let's go here. All right. So this will become negative 1 times, you have here 4 times the square of negative 1, which will be equal to 1 minus 1. All right. So we have here negative 1 times multiply. We have here 4 minus 1. So in here we have negative 1 times 3, which is will equal to negative 3. All right. So let's move on in getting the limit of the quotient of two functions. We all know that it is defined in the last video that if we're going to get the quotient of the function f and g, or the limit of these two functions, we just getting the limit of their quotients. All right. So let's apply this law by having an example number 1, which is, let's say we're going to get the limit of 3x plus 2. This is your function f, all over, let's say, 2x. This is your function g. As your x approaches, let's say, let's use negative 2. All right. So in here, we're going to apply the law of the quotient of two functions. So this will become, get first the limit of your function f. This will be limit of your 3x plus 2 as your x approaches the value negative 2, all over the limit of your function g, which is 2x as your x approaches negative 2. All right. As you can see in your function f, we can basically use the sum and difference of these two functions. So we can expand this one for us to get their individual limits. And also in your function g, we can basically use the constant multiple law. All right. So in here, this will become the limit of 3x as your x approaches negative 2, plus the limit of 2 as your x approaches negative 2, all over the limit of your g, or let's say this will be 2x as your x approaches negative 2. All right. And by using the constant multiple in the first term of your numerator, and get by using the constant multiple here in your denominator, this will be equal to 3 times the limit of your x here, or let's use parenthesis, x as your x approaches the value negative 2, plus the limit of your constant 2 as your x approaches negative 2. All right. All over, by applying the constant multiple here, this will become 2 times the limit of your x as your x approaches negative 2. All right. So let's put equal sign here. So this will be equal to, let's simplify this limit by applying the constant function, the limit of the identity function. This will be equal to 3 times negative 2, plus applying the constant function. This will be equal to 2. All right. All over, you have 2 here times the limit of your x by applying the identity function here. This will be equal to negative 2. All right. So we have here, let's simplify this. You have 3 times negative 2, which is negative 6, plus 2, all over 2 times negative 2, which will be equal to negative 4. So by simplifying this one, we have here negative 4 all over negative 4, which is also equal to 1. All right. So the answer here is 1. If you get the quotient of these two functions, 3x plus 2 all over 2x, as your x approaches negative 2, your answer here will be equal to 1. All right. So let's move on to the last limit law, which is the limit of the nth root of a function. And we all know that it's defined in the last video that if we're going to get the limit of the nth root of this function f as your x approaches any value, so this will be equal to the nth root of the limit of the function f. All right. So let's have here an example, number 1. All right. So we're going to get the limit of, let's say, the square root of your function f. Let's use 3x plus 1. All right. As your x approaches 5. All right. So here we're going to apply the limit of the root of a function. And by applying this law, this will be equal to the limit of your 3x plus 1 as your x approaches 5 and before you get the square root of this function. All right. And as we get their individual limits, we have to apply here the sum of the two functions. So this will be equal to the square root of the limit of your 3x as your x approaches 5 plus the limit of 1 as your x approaches 5. Alright? And basically, in this first term here, we can use the constant multiple here. And in here, in your second term, we can basically use the constant function or the limit of the constant. Alright? So in here, we can have 3 times the limit of your x as your x approaches 5. Alright? The constant multiple plus the limit of 1 as your x approaches 5. All right, so let's move here. So this will be equal to, by applying the basic limit laws, which is the identity function and the constant function, we have here the square root of, we have 3 times identity function, which is 5, plus the limit of this constant function, which is equal to 1. All right. So we have here the square root of, what is 3 times 5? You have 15 plus 1. So you have the sum of 16. And by getting the square root of 16, this will be equal to 4. All right. So your final answer here is 4. If you get the limit of the square root of 3x plus 1 as your x approaches 5, your answer here will be equal to 4. All right. And we will use this all the basic limit laws to deal with those complex limit problems that you've seen in the first part of this video. And we're going to put it in its simplest compound and get their individual limits. So now let's answer this limit problem that really seems hard in the first look and basically break it down to the point where we can use those basic limit laws and get the individual limits and see what we can do. So let's start with getting the limit of this function by applying first the law of the quotient, all right? The quotient of two functions. So this will be equal to the limit of 1 minus x squared as your x approaches 2 all over the limit of your square root of 2x, all right? As your x approaches 2. Now, how can we simplify this? As you can see in the first, or I mean in the numerator of this rational form, right? You can apply the sum and difference of two terms here. And in your denominator, you can basically apply the root of a function. So this will be equal to the limit of 1 as your x approaches 2 minus the limit of your x squared as your x approaches 2 all over, using or by applying the root of the function. This will become the square root of the limit of 2x as your x approaches 2. All right. So in here, we can basically use the constant multiple. So let's move on to this one. All right. So in the first term of your numerator, that's the constant. You can basically simplify this by using the constant function. And your second term, let's apply here the power of a function. So this will be equal to the limit of 1 as your x approaches 2 minus the limit of your x. Get first the limit of your x as your x approaches 2 before you raise it to your exponent all over the square root of, let's apply the constant multiple here, 2 times the limit of your x as your x approaches 2. All right. So basically, you can get the individual limits. In here, apply the basic limit law, which is the constant function. Here, the identity function. And in your denominator, apply also the identity function. So let's move on here. This will be equal to, let's start here by applying the constant function here will be equal to 1 minus, apply this identity function. You have here 2 and raise it to your exponent 2 all over the square root of 2 times, by applying the identity function, this will be equal to 2. All right. So by simplifying this, the numerator, you have 1 minus 4 all over the square root of 4. And by simplifying this, your numerator will be equal to negative 3, and your denominator will be the square root of 4, which will be equal to 2. All right. So if you simplify this, if you get the limit, I mean, if you get the limit of this function, f as your x approaches 2, the limit of this will be equal to negative 3 all over 2. So that's how we apply the basic limit laws and put those complex limit problems in its simplest compound and get their individual limits. All right. So if there will be more examples in the next video, we will basically break it down to the point where we can use those basic limit laws and get their individual limits and see what we can do. All right. So see you in the next video.